Hello, algebra. So you've already seen this before, just reminding you that you know how to write out these exponents as long rules. But I also wanted you to find out about our final two rules, all right? Our final two rules for exponents. So that is the zero and the negative exponent rule, all right? Now, for our zero rule, it's a very, very simple rule. Very, very simple. Anything raised to zero equals 1. And some of you might look at me and go, wait, what? Here's what I mean. If we have 5 to the 0, let's just see how we could get an exponent that has a 0 power. How could we do that? How could we get an exponent of 0? What could we do using our power rules? Well, let's just say I had a 5 to the 1 times 5 to the negative 1. My product rule says I would have to add those, right? So I'd get 5, 1, minus 1. That would become 5 to the 0. Now, this negative exponent, what that actually means, if we look over here, is that if it's in the numerator, we move that to the denominator. If it's in the denominator, we move it to the numerator. Another way of thinking about it, and this is an analogy I had a student tell me, is the negative means that that exponent's not happy. So we have to move him to where he will be happy. If he's already living in the attic and he doesn't like it, then we need to move him to the basement. If he's living in the basement and he doesn't like it, we move him to the attic. Okay? So in this case, this is really 5 to the negative 1 over 1. So because it's a negative, I'm going to have to move him down. So this becomes 1 over 5 to the 1. So when I look at this, what this is really saying then is that I have a 5 to the 1, and then I move that, so I get 5 to the 1. So it's positive, right? Well, 5 divided by 5 is 1. So that's why anything raised to the 0 is 1, is because it actually means that we've basically divided it by itself. So if it's easier for your brain, just go, cool. Anything to the 0 is 1. Great, do that. If you really like my way of showing you, that's awesome too. So anything raised to the 0 is 1. And negative exponents just mean that we need to move them. So if they're in the denominator, we move it to the denominator, and the exponent turns into a positive. So in this case, for example, it is in the numerator, right? It has a denominator of that ninja number 1. So I need to move it to the denominator. So it becomes 5, and now the 2 is positive. Now he's happy living in the basement. So let's do it with this 2 down here. We've got 2 to the negative 3. So I'm going to move it so that it's in the denominator. But wait a second, what goes in the numerator? 1. All right, remember, any number always has a ninja number 1 in the denominator. It's always there. You just don't always see him. He's a ninja. All right, so for this one would become a 1 over negative 3 to the 4th power. And we could actually use our product rule to simplify that out further, right? So I'm going to write it out long ways so you can see it. This would be negative 3 times negative 3 times negative 3 times negative 3. So that's really 1 over negative 3 times negative 3 is a positive 9. 9 times 9 is 81. So it's really 1 over 81. And remember, with this one, we need to be careful because that negative 4 is only touching the 3. It's not touching the 1. It's only touching the 3. So this is really negative. Now I have to move this to the denominator. So it'd be 1 over 3 to the positive 4. Hey, what is that? Well, we just said negative 3 to the 4th was 81. So 3 to the 4th is 8. It's negative 1 over 81. Hopefully you know most of your powers pretty well, at least through the cubes and some of the force. I think 2 to the 5th is probably one of the easiest ones. 2 is in general, right? Because it just keeps doubling. 3s, it gets pretty complicated and pretty big quickly. All right, so there are plenty of other problems to try on this page. I will do this one with you. So we've got a -5 here. That means that this whole thing needs to move to the denominator. So we get 1 over -1 to the positive 5th power. And again, you can take that further, but for now we're just playing around, not playing. Well, hopefully it's playing. Hopefully it's fun to you. Right now we're just working on our negative exponents. That's what we're working on. All right. Hopefully you had a chance to try a couple more on this page. Get pretty familiar with our 0 and negative exponent rules, because we're going to try some more of them. All right, we're going to try some more. So for our first one up here, we want to simplify all of these, okay? If it's got a negative exponent, we just want to simplify it. So we've got 3y to the -2. Now this -2 is only touching the y, all right? Our 3, it's not touching. So the 3 is just going to stay, which means the y is the one that moves to the denominator, and then our 2 turns positive, all right? So our 2 turns positive when we move the y to the denominator. For our next one here, we have a -4 over k to the -4. The k, the -4 in the denominator here, the exponent, is not happy. So that means we have to move our k to the numerator. So our -4 hangs out up there. And then the k moves up and turns into a +4. And then our denominator just has a 1 left over. So do we have to write that 1? Of course not. All right, we're going to go through this one step at a time. Okay, one step at a time. And I like to go alphabetical. So we're going to start with the A. A to the 0. Anything to the 0 is always 1. X to the -3. Wait, it's a negative? That means I need to move it. So it moves to the denominator and the x turns positive. And then we have a y to the 5th power. It's a +5 though. What do we do with that? We just leave it. He just hangs out. He's happy where he is. But what goes in my numerator now? 1. Right? There's always a 1 there. You just don't always see him. Because how many x's do we have? 1. So he was still there. He was there all along. All right, let's take a look at this one. We're going to, again, go through this one at a time. So this 2 has its own exponent. All right, it has its own exponent. The 0 is not touching the 2. The -3 is not touching the 2. The 2 has an exponent. He's just a ninja. That's right, it's a 1. So I'm just going to leave my 2 there as he is. I'm not moving him, not doing anything to him. His exponent is 1. He's happy. R to the 0. That's actually going to turn into 1. And then we've got an m, and it's to the -3. That -3 means we have to move the m to the denominator. So we get an m cubed. So when I rewrite this, I end up with 2 over m cubed. And that 3, when we move the m to the denominator, the 3 turns positive. All right, let's take a look at our next one here. We've got an r to the -3 over 7. What is the exponent of this 7? He has an exponent. It's 1. So what do we need to do with the 7? He's got a happy little 1 there. Nothing. We just leave our 7. So now we have to look at our r. Our r has an exponent that's -3. That means we need to move the r to the denominator. So this becomes r cubed. Wait a second. What's in the numerator? A 1. So this is really 1 over 7 r cubed. I'm going to slide this up some. All right, let's do this one next. So we've got g to the 4th divided by h to the -6th. G to the 4th, what do we do with him? Nothing, he's happy. So we just let him hang out. And then we've got an h to the -6th. That negative means it's not happy. We need to move him to the numerator. So that becomes h to the +6th. So our end result is g4 h to the 6th. Oh, excuse me. All right, for this one right here, t to the -9. That -9 means it's not happy, so we need to move him to the denominator. So it becomes t to the +9. Wait a second, what goes in our numerator? 1. He is always there, you just don't always see him. All right, let's work on these 4 next, because I know this is kind of weird. So we've got 3 n to the negative 2. There is an exponent for the 3. It is a ninja number 1. So when I go to rewrite this, my 3, do I need to do anything to him? No, he's happy. The next one is an n to the negative 2, right? That negative 2 only touches the n. It does not touch the 3. It only touches the n. If it touched the 3, we'd have parentheses around it or something, right? It doesn't touch the 3, though. It's just the n. That negative 2 means it's not happy. So I need to move my n to the denominator so the 2 can turn happy. All right, for our next one here, we've got 2/3 x to the 4th. So my 2/3, they both have exponents of 1, so they just hang out. They're happy. We don't need to do anything to them. It's our x to the negative 4 that's the issue, right? Now, we need to decide, is the x in the numerator right now, or is it in the denominator? If it's just hanging out like this, just like it was with the t to the negative 9 here, it's in the numerator, right? Any number written, we always assume is in the numerator. So that means I need to move him to the denominator and turn our 4 positive. So it's really 2/3x to the 4th. All right, let's take a look at this one next. Start with your 10. What is its exponent? 1. This negative 3 does not touch the 10. The 4 does not touch the 10. The 10 is all by himself. All right? So I'm just going to leave my 10. He's happy. He's fine. Don't need to touch him. He's good. Then we've got an r to the negative 3. All right? That r to the negative 3, I need to move him to the denominator so he can turn happy. So it becomes r cubed. And then we've got an s to the 4th. What do we need to do with him? Nothing. We just leave him. S4. He's happy. So we don't have to do anything to him. Actually, I'm going to skip that one. I'm going to look at this one down here. This one has a lot more stuff to it. And so, yeah, I think this one would be better. All right, let's take it one variable at a time. And I like to go in alphabetical order. So let's start with the p. All right, so p to the negative 9. It's in the numerator. It's not happy. That means it needs to move to the denominator. So we get p to the positive 9. So when we move it, the exponent turns positive. When we move it, the exponent turns positive. Q comes next. We've got q to the negative 4. Not happy in the numerator. We have to move it to the denominator, so it becomes q to the positive 4. Next one is r squared. What do we do to it? It's positive. He's happy in the denominator, so we just leave him. He's an r squared. And then we have s to negative 3. It's a negative in the denominator, so we have to move it, so it becomes s to the positive 3 now in the numerator. Right, now in the numerator. All right, so try these out. When you come across things that have a 0, like z to the 0 here, remember that they are 1 for this guy. Okay, just 1 out. Email me if you have questions. I am happy to help.